Hello everyone. Today I'm going to give you an example of working with systems of linear equations. So there's a word problem and I'm just going to go through it with you. RR, I guess that's the name of a company or a person or a business. RR purchases gearboxes from the Metallist for $5.77 per gearbox plus a one-time credit check fee of $45. RR sells each gearbox for $8.50. Okay, the first thing we want to do every time is we want to underline or circle the most important information that we think, okay? And we might circle the wrong thing, but circle what you think is best, okay? So for sure anything with numbers is usually important. All this right here, that looks important. And RR sells the gearbox for $8.50. Okay? So a system of linear equations is basically more than one linear equation that relate to each other, okay, or the scenario. So let's just go ahead and write one. Let's start off with the first one, and we're just going to label them y equals, okay? Y equals says 577 per gearbox, okay? So 577, and we can use the variable x because it's per gearbox. So 577 times one gearbox, 577 times two gearboxes, 577 times 10 gearboxes, okay? That's why it's 577x plus a one-time credit check fee of $45. So that's a one-time fee. $45. Okay? That's one linear equation. Let's do the other one. RR sells each gearbox for $8.50. Pretty easy. Y equals 850 times x. Again, x is the number of gearboxes, and I'll write that down here. X equals number of gear boxes. All right? So now we have two functions. Two equations here. Systems of linear equations, so we have two. And that makes the system. Now from here, let's go ahead and do a couple things. Let's go ahead and find the break-even point. So break-even point is basically where your expenses and the amount of money and your profit kind of like meet. Okay, so at first you're not making really any profit yet, but as time goes on, it's hopes that you're going to make profit, and that point where the two lines meet, that's your break-even point. So just to give you a visual example of this, let's call this A, and let's call this B, okay? Now, if we were to graph this system here, which is both equations, okay, let's go ahead and graph A, and then we'll graph B, and then we're going to see where their break-even point is. So basically where they're going to cross, okay? And I'll do the colors accordingly. So let's go ahead and label these. X-axis we'll go by fives. 10, 15, 20. And then we'll go by 50s for the dollars. And hopefully this is enough space. Okay? So the easiest way, if you don't know how to graph this, is to just make a table. Okay, and I'll do that down here. What was it? 577x plus 45? So when x is 0, 577 times 0 plus 45 is just 45. Because this cancels. Okay? When x is 10, actually we'll just do, yeah, when x is 10, and I just skipped around. This is 0 here. 577 times 10 plus 45, just move it over 1, is 5770 plus 45 is, I don't know. $102.70. Okay? And we'll just leave it there for now. So at 0, it's going to be 45, which I'm just going to say is like right here. And then at 10, x is 10, it's going to be 102.70. Like right there. Okay? We draw a little line. Hopefully your lines actually connect. Okay? Now we're going to go ahead and graph B. Okay, we're going to graph this one now. And we can make a table again. 850x. We'll do 0. 850 times 0 is 0. And we'll do 10. 850 times 10 is 85. Okay? $85. So 0 and 85. So when x is 0, y is 0. And when x is 10, y is 85. About right here. So if you look at the graphs, at the rate they're going, and I know my lines aren't straight, I'm not using a ruler. At the rate they're going, the break-even point is like right here. Okay? That's the break-even point. That's also when two functions cross that point of intersection. The intersection is another word for when they cross each other. That is the number of solutions. And in this case, they're only going to cross one time, so it's one solution. One intersection. One solution. Okay? Now, our graph isn't beautiful. I get that. But we can kind of figure out the answer. You know, kind of an estimate. We know that it'll be what? Maybe 17, 18, 19 gearboxes. They need to sell in order to break even. So at this point, on the blue, after this point here, when they saw 20 gearboxes, 25 gearboxes, 30 gearboxes, 35, now they're making profit at that point. But before that, any gearboxes sold before, let's say 17, like 15, 10, 12, 5, they weren't making profit yet. Okay? Because you can see at 10 here, it touches blue. And they're still not making profit because the green is higher. And the green was right here. Okay? It might be a tough concept to understand, but key takeaways, and I'll summarize it down here. I'll just write there. Summary. More than one linear equation makes up a system, and they usually have the curly braces. Okay, so y equals 2x, whatever, y equals 3x minus 5. That's a system of linear equations. When the two linear equations intersect, and again, intersect means they cross. When the two linear equations intersect, that is a solution. So, one intersection, no, I'll write that in red. One intersection, one solution. Two intersections in which linear equations won't intersect twice, but I'm just giving you the example. Two intersections, can't spell, two solutions. Okay, get that idea? And then also when they intersect, that is the break-even point. And I'll just put it here. One intersection, one solution. I'll write it as its own. In a system of linear equations, the intersection is the break-even point. And remember, it's only the break-even point when the scenario itself is talking about business and money, and it costs this much to make the toy, and I'm selling it for this much, because break-even point is a business term. Okay? So this is only according to the scenario. If a business scenario problem. Okay? Something along those lines. Alright, so hopefully this video wasn't too confusing, and I hope you kind of understood what we did. All we did again is we created our system here, created our system. Each of these equations models from the scenario. This equation models from the scenario. And the two equations make up the system of the whole scenario. And we basically just graphed each one. That's it. We graphed each one individually. A was green. Blue was blue. Graphed it. Found out where they intersect. And then we just deciphered from that point of intersection, what does that mean? What does the answer mean? Okay? And I wrote it there. And again, sometimes it's going to be hard to get the answer. And according to our pictures, you can get more precise with a graphing calculator or Desmos. And I just made a quick table for each one. For the green line, green equation, and for the blue equation. And I wrote up a quick summary here. Okay? Alright everyone, hope this video was helpful. See you guys next time. Peace.